use. So let's say we've got a bracket that is x plus y to the power of n. Okay. And so what's going to happen is this is going to expand and we're going to have lots of terms, okay? Now for the simplest one, let's say we had our x plus y squared. Well, hopefully you tell me that I need each of the individual terms squared on the end. And then in the middle, I'd have two lots of the terms multiplying. Okay, now this middle term, you could also have found using FOIL or just multiplying it out in full. But what I see here is that I go from 2 power to 3 terms. So that's the first thing we can talk about, the number of terms we're going to get. So for an expansion to the power of n, we're going to have n plus 1 terms. So before we even look at finding any of the terms, we know how many we're expecting. Now, if I look at my expansion for the squared one, I've got something to do with x and y in most of my terms. So I always break down an expansion into 3 parts. Part 1, we've got, say, the x term. I'm putting these in inverted commas because sometimes it's not x, it might be 3x, it might be x squared, but it's the first term in the bracket. Then we have our y term, which is the second term in the bracket, and then 3, our binomial coefficient. And if you're happy with how to find all 3 of those individually, if you multiply them together, you get a single term. And we need to do this as many times as I have terms. So let's take a nice straightforward bracket to begin with. So let's say I've got x plus 1 to the power of 4. Well, this is going to be the same as doing x plus 1 multiplied by itself 4 times. Oh. Okay. Now, the way to think about it is I imagine like each of these brackets is kind of like a bag, and I put my hand into each of the 4 bags and I either pick out an x or I pick out a 1. So let's say the first time I can pick out 4 x's. So when I multiply all these terms together that I picked out of my bag, I'm going to have x to the power of 4. Well, if I picked 4 x's, then I have 1 to the power of 0 because I picked 0 ones. And we'll come on to the coefficient in a little bit. Now let's say I pick 3 x's and then a 1. Well, that means that my next term, where I picked x to multiply together 3 times, and I've picked 1 to multiply together once. Okay? And then again, we'll have our choose term. And so we can continue like this until the end of the expansion. So finishing it in black in full, we're going to have x squared, 1 squared. If I have x to the 1, 1 to the 3, and x to the 0, 1 to the 4. So while I'm doing this expansion in a very sort of slow, long-winded way, just so that everyone's happy with sort of where it comes from, but you can remember this in terms of a shortcut as your first term starts at the bracket power and decreases by 1 each time. And then the second term is going to do the opposite. So the second term starts at 0 and it's increasing by 1 each time. Now in general, this means if I look at each of the pairs of powers, 4 and 0, 3 and 1, 2 and 2, each pair of powers, or each power pair, as my hand decided it was going to be written, it adds to the bracket power. Okay, so if I know what power of x I need, I can work out what power of the other term I need by making sure they add up to this 4 that we had here. Now, the spaces I've left for my numbers are my binomial coefficients. So this is my x and my y term as I described them earlier. Now, my binomial coefficient tells me how many ways to choose that combination. And some of you may discuss or may describe your binomial coefficients as something like 4 choose 2. Okay, so let's look at this first one. Well, I picked 4 x's, and my binomial coefficient is going to describe how many ways there are to pick 4 x's from the 4 available. Now we write this. I'm going to use my notation, but you're fine to use the other notation. I write 4 choose 4. So I've got 4 x's to pick from, and I need to choose 4 of them. Now we'll come on to the value of this, but this is actually going to be 1, and we'll explain this underneath. But that's because there's only one way that I could have picked the 4 x's from 4. I just had to go x, 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 x. Okay. Now the second one is 4 choose, and now I'm choosing 3 x's. So what I'm thinking is, how many different ways are there of picking 1, 1, and 3 x's? Well, I could have picked this one, or this one, or this one, or this one. So the value of this, we'll see later, is going to be 4, and so on. But the important thing is, especially if you're in your calculator, you can just write these coefficients just like this. Okay. So to recap the binomial coefficient, its relevance is, well, we've already said the number of ways of getting this combination, but we can always write it as the bracket power choose one of the term powers. And you could use either. Okay, you may also, so for example, this could be, say, 7 choose 3. And the way to write it, if you don't use that notation, is 7, 3. Like, it kind of looks like a vector. And that's why I prefer this 7 choose 3. Firstly, because it's just completely separate. And secondly, because this is actually what you're going to type in your calculator. So to me, that makes a lot more sense. So if you calculated all of this, you've just done a full expansion. So let's look at this binomial coefficient and ways to calculate it. Well, there are 3 ways that you're going to use to calculate it, and I'm going to recommend each one in individual ways. So first one, calculator. So for your calculator, you're going to use your NCR button, which on Casio is if you go options, F6, and then it's in probability. And then, I never remember the TI. I was always a Casio user. For the TI-84, I think it's something like in math, and then you want it on, again, PRB. If it's not in PRB, it might be a number. But if you're ever not sure on how to use your calculator, then just Google it or YouTube it. There was one time I was teaching, and this lady called Marjorie taught the whole class how to do linear regression. It's super simple, like literally just Google TI-84 NCR, and it will show you how to press it. So do that with anything where you're not happy on how to use it on your calculator. Now, step 2, which is what I recommend. So this calculator one is great, obviously only for paper 2 and for individual coefficients. It's super quick, but you need to know the powers. So the second one is going to be our formula, which a lot of people seem not to like, but I think it's one of the quickest if you know how to use it. And this is that NCR is equal to n factorial over r factorial n minus r factorial. Or in other words, this is the bracket power factorial over the product of the term powers, both factorial. Okay, so for example, this 4 choose 3 is 4 factorial over 3 factorial 1 factorial. Now, the way I'd write this, let's say we're doing 8 choose 5, which most people would be like, oh, I don't want to do that by hand. So start with the bottom. So we write our 5 factorial, 3 factorial. Now, factorial means that we multiply down to 1. And just also as an aside, 0 factorial confusingly is equal to 1. So on the top, instead of writing 8 factorial, I can write 8 times 7 times 6. And then I get to 5 and below. But I know that 5 and below is 5 factorial. So I can cancel this. And I always do it the biggest one to get rid of most of my numbers. So this becomes 8 times 7 times 6 over 3 times 2 times 1. Well, 3 and 2 makes 6. So 8 choose 5 is 56. And I would especially expect you to be good at this calculation if you're a higher level student, because this is something they'll do to make things nasty. Now, when to use this is best for paper 1, individual terms or individual coefficients, and especially unknown bracket power. And then the last one, which we'll very quickly go through, is Pascal's triangle. And so to set this up, write a 1. And I like to think of, have any of you been at like a party or seen on like a film or whatever, when they've got loads of glasses all stacked up in a tower, and they pour into the top one and it trickles down and trickles down. And then there are some which have liquid pouring in from both sides. That's sort of how I imagine this. So we're pouring down and the numbers trickle down left and right. So we have 1 and 1. And then these are going to trickle down left and then right, but they're both going to trickle into the middle. So we get 2. And that's how I think of it. And yeah, I mean, you could just remember that you keep adding up, but I don't know. I think drink pouring into glasses is a bit more vivid to remember. So we can keep going, keep going. Now, the first thing to say is only use this for a full expansion. There's no point making a list of coefficients for just one term. Also, use it for bracket powers less than about 7. Because you can see already I've had to work out, 6, 10, 15, 21 numbers just to get the 5th row. So first of all, it's a lot of work, but secondly, if you make a mistake in your 2nd row, then you're screwed for your 7th row. So keep it to low powers. And the way you use it is the row that you're looking at is equal to the bracket power. So again, confusingly starting at 0, 1, 2, 3, 4, 5. I mean, the other way you could remember it is that the number here is which power we're at. And then along the row, we have the terms. So this will be 5 choose 0, 5 choose 1, and so on. So it doesn't matter which of the terms powers you look at because it's symmetrical. Okay, so 5 choose 2 is 10, and 5 choose 4 is 5. Some general rules that are useful, and you can either use...
I hope you enjoyed the video. If you did, be sure to click down here to like, subscribe, and share with a friend. If you'd like to access the full online course, including the notes pages we were making, there's a link in our description below. Thank you for watching, and good luck with your revision.